Hey, Monica. Sorry about all that mess. Um, so, we're going to talk about parent functions. This section is about recognizing the basic ways, the basic forms of the graphs of basic functions. So, we have a constant function, y equals 5, or more generally, we could call it y equals c. That means the y-coordinate is always the same no matter what x is, and that's a horizontal line. Y equals x, that's the simplest way we can write a linear equation. And frankly, if you think of it in terms of y equals mx plus b, it's got a slope of 1. This would be a 1. And it's got a y-intercept of 0. And that's what this graph does. Y equals x squared. That's a parabola. It's centered, its vertex is at the origin. Notice every one of these parent functions, well, not the constant function, but most of these have to do with the origin. Y equals x cubed. When x is positive, it goes up fast because I'm cubing it instead of just squaring it. But when x is negative, whereas here, squaring a negative makes it positive, so all those values were positive. When it's cubed, a negative number for x stays negative because I'm cubing it, and that's a negative times a negative times a negative, which is negative. When I look at y equals the square root of x, I can't plug in negative values of x because that wouldn't be a real number. You and I have talked about complex numbers, but we're not talking about complex numbers here. When I let x equal 10, let's say when I let x equal 100, y is positive, but y is only 10 when x is 100. So the graph is not going up very fast. Y keeps getting bigger, but it's not getting bigger as fast as x gets bigger. And then here we have an absolute value function where the parent function has, and in all of these things you can draw a table. I could have called this f of x instead of y, like for that absolute value function. I could have said when x equals negative 2, the absolute value of negative 2 is 2. When x equals negative 1, the absolute value of negative 1 is 1. When x equals 0, the absolute value of 0 is 0. When x equals 1, the absolute value of 1 is 1. And when x equals 2, the absolute value of 2 equals 2. And you can see how we're starting to create this graph using this table. So that's, there are a whole bunch of parent functions. This is another one that shows up in this section. Y equals 1 over x. Well, what happens when I let x equal 10 or 100 or 1,000 or 1,000,000? Y gets smaller and smaller and smaller. It stays positive, but it gets closer and closer to 0. When I let x equal 1, then I have y equals 1 over 1, which is 1. So then it hits this value, 1. So I get the 0.11. And then as I let x get less than 1, but still positive, I get y equals 1 over 10 and 1 over 100 and 1 over 1,000. And, 1 over 1,000th. And that makes y get bigger and bigger and bigger. When I let x get negative and big, I get 1 over 1,000. negative 1,000, and that's a very small number, negative. And then x goes to being, I'd get this point when x is negative 1, y is 1, negative 1. And then the graph would go like this. So that's an unusual but somewhat important parent function. That's most of the first section. The other thing that the section you're going to do, hopefully by tomorrow, is the other thing it talks about is piecewise functions that we've talked about before. I am going to stop this video, and then I'm going to do another one on piecewise functions that we've talked about, and I think those are likewise pretty easy. All right, so I'm stopping this one. I'm going to send this to you, and then I'm going to send another video to you, Monica. Okay, thanks.